Welcome to the World Center for Concrete Technology. My name is Eric Krebs. I'm one of the co-directors here at the center, and I'm pleased to host this video on concrete masonry production. As you can see from the building behind me, the World Center for Concrete Technology is made out of masonry. Masonry has a lot of attributes. One is that it's very pleasing to the eye. Also, structural integrity would be another commodity. It's the intent of this video to show you what goes into making concrete masonry, or CMUs. Those would be materials such as sand, stone, cement, and water. In the application behind me, there's also pigment or color in this process. We're going to show the mixing, the proportioning, how we mix that recipe together, how it goes through a concrete products machine. Then we'll convey it to a curing chamber. Coming out of the curing chamber in X amount of time, we'll go down an unloading line, and then it will be going through the cubing system that will package the product and put them in the yard for storage. Most block companies have many different sources of aggregates. Those sources of aggregates come into a yard typically, and they're either dumped in piles, like this particular pile of sand, or they're dumped underground with conveyors going up into holding hoppers or holding bins. As we talked earlier, our particular mix design is going to be sand, stone, cement, and water. So what I'm going to do is take a sample of our 2NS, which is 2 natural sand. 2NS, it's a MDOT designation. Now I'm just going to take a sample of it. But before I do that, I want you to understand that there are sampling methods, and I'm not conforming to those particular methods. So what I'm going to do is just take some sand, and we'll take it back into the laboratory, and we will do a sieve analysis on it. So this is the typical sand that I will use. This is what we call our stone. Some have other designations, number 8, number 9, maybe a P stone, but in our case we call this 29A, another MDOT designation. So I'll take a sample of that also. Once I've got my 2 samples, sand and stone, I can go back to the laboratory and do what we call a sieve analysis on these 2 aggregates. Welcome back to the lab at the World Center for Concrete Technology. We're still talking about the ingredients that go in a concrete masonry unit. This is the sample of sand that we took from the pile a few moments ago. I have to do a few more things to this particular sample of sand to get down to a mix design for that concrete masonry unit. So the first thing I've done is I've taken that sand and I've dried it out in an oven. You may see that it looks a little different, but it just has the moisture removed. I've also got my 2NS sand, and I've also got my 29A. That's my stone. The other ingredient, as we've talked about, was Portland cement. This is a type 1-2 Portland cement. The last ingredient, water. In what proportions is our next quandary. As these are proportioned and mixed together, it's our intent to make a concrete masonry unit. However, this is a miniature block and does not conform to the standard block size of an 8-inch by 8-inch by 16-inch concrete masonry unit. So next in the process is taking this sand and getting it down to a sample size that I can use for a sieve analysis test. And by the way, all these tests are done in accordance to ASTM specifications. I've taken a few liberties that a normal lab would not. So what I've done now, the next step would be to put this aggregate, the sand, into a riffle sampler and break down the material to a sample size that I can use. I've done that ahead of time. So this is what I've got for a sample now of the sand, the dry sand. So now I would take my dry sand, which should be about 500 gram sample, but I want to make sure of this weight and exactly how much of this material I have. So I'm going to take it over to a scale and make sure I get that weight. And yes, I have about 500 grams. This happens to be 488. but I use that total sample. And now what I'm going to do is break that sample down into each individual particle sizes within that total sample. And I do that through a sieve analysis. So I'll start that process. In the sieve analysis, we have screens. These screens have holes in them, and those holes represent the size of a given particle that will pass through them. This happens to be a number 4 screen. What does the 4 mean? 4 means that there are 4 openings per linear inch. The next size down would be a number 8 screen, and of course, correspondingly, 8 openings per linear inch. As I go down finer and finer, 16 openings per linear inch. So I think you can see by this that as material passes by these particular screens, it's going to retain a certain amount of material on each screen, and that is what we're going to call the percent retained. So to do that, I take that 488 gram sample that I weighed out, and I'm going to pour this into the top screen. Once I've done that, I'm going to put the top on, and then again, according to specifications of ASTM, I'm going to shake this sieve for approximately 4 to 6 minutes. That's the next process. I'm going to put the screens, the nest of screens, into the shaker, put the top down, and set my timer for approximately 4 to 6 minutes. It depends on how many sieves you have is the amount of time that I'm going to shake for. And I'm going to let that shake for that allotted 4 to 6 minutes. At that point, I'm going to take it back and find out how much material is on each individual sieve. So now I take the top off, and I would see the particle sizes that are on this particular pan and find out how much each particle size weighs. That way I'm breaking the particle sizes down, and I'll relate to that in a moment. So as I look over at the particle sizes that came out of these sieves, I have the same numbers: 4, 8, 16, 30, 50, 100, and pan. You'll note that the size of the particles goes down as the number gets higher. So this was all that was actually retained on that number 4. This was the only retained on the number 8, and so forth till I get down to my pan or my very fine dust. Why would I do this? Well, that's going to tell me, once I do the calculations, I can put this in a computer and tell the fineness or the texture that this block is going to have. Now remember, this is only processed with just the sand. I'm going to do the same process with the stone. At that point, I'll graph it, put it on a graph, and then that will tell me if I need 20% of the stone, 80% of the sand, vice versa. Those proportions will tell me what to do with that particular block. Of course, then I'm going to add the cement, and I'm also going to add the water. To put it into proportions for you, it's going to be about 1 part cement for every 10 parts of this combined aggregate. And of course, we're going to have that water. Once that is mixed up, I can start putting it through the block machine and make our concrete block. We're going to head to the block plant now and show you that process of weighing up the material, mixing these materials, but on a much broader scale. One of the first things we need to have is a continual supply of those materials we have just talked about. The white silo is where the cement is being stored. This particular silo holds 50 to 100 tons of cement. Next, we're showing how to transport the aggregates from the piles in the yard to the storage bins inside the facility. We are using dump hoppers and a conveyor system that conveys those materials to individual bins inside the building. When the materials enter the building, they are shuttled to individual bins that hold the same type of material. These bins each hold 50 tons of material. So in theory, I can store 300 tons of 6 different types of materials inside this building. Once we've gotten the proportions of the aggregates to be used in the final mix design, these clam gates drop that predetermined amount of material onto weigh belts. From there, the sand and stone are weighed. The conveyors transport the aggregates toward the mixer. This particular mixer has a capacity of 6,000 pounds, which is considered one batch. Once the aggregates are in the mixer, the cement is added along with the correct amount of water. This is all an automatic process. Typically, this material only requires about 6% total moisture. All the materials are mixed from 4 to 6 minutes, and then the mixer gate opens, transferring the mixed material to a holding hopper behind the block machine. From there, the material enters a small hopper directly above the block machine. In this short production run that you're seeing, we are making CMUs that are 8 inches by 8 inches by 16 inches, 3 at a time. So approximately every 7 to 8 seconds, we produce 3 units. Notice that they are being produced on a steel pallet. This is a production rate of approximately 21 blocks per minute, or 1,260 blocks per hour. The moisture percent, the mix design, and the configuration of the blocks being produced determines these cycle rates. Next, the blocks are conveyed on the front delivery conveyor toward a stacker. Notice that the blocks are being checked for the correct height at this stage, and then the tops are being brushed off to eliminate any imperfections. The blocks are first stacked in a loader 9 high, and then a spade moves from the loader stacker into the rack. These racks can carry 324 block or 108 pallets. Now the racks are being shifted out of the way, awaiting pickup from a crawler that goes underneath the rack, picks it up, and transports it back to the car. Once the rack is back on the car, it is transferred to the kilns for curing. This curing can take as much as 24 hours at approximately 120 degrees Fahrenheit. Once the green block rack is deposited, the car then picks up a cured rack and brings it back to the unloading station. The cured block are then conveyed down an unloading line. As they go into a depalleter, which pushes them off the steel pallet, the empty pallet is then recycled to the back of the machine for reuse. Then the blocks are conveyed toward the cuber. This cuber packages the block to conform to the customer's request. The series of turntables automatically accomplishes this task. Then each tier is stacked on top of the other using a wooden pallet. Once this is accomplished, the full cube of 90 blocks is pushed out the door and awaits pickup by a forklift. This operator either stores the cubes in the yard or places them right on the truck for transportation to the job site. Well, you've just had a tour of the World Center for Concrete and its block making facility. We started out with sand, stone, cement, and water. And now we've got a product that'll pass all the specifications and standards in our industry. It was my pleasure to host this video at the World Center for Concrete Technology. And I'd also like you to remember that we are a research facility to helping masonry and masonry aspects around the world. We also train block makers from all over the world. We are a lab for Northeast Michigan for all types of concrete. And we also house a 2-year associate's degree in applied science for concrete technology. And if you've got any questions, please don't hesitate to call us at the World Center for Concrete Technology here in Alpena, Michigan. Please visit our website, and remember, if you're going to build it to last, and build it out of concrete.